When NASA conducted its long-anticipated press conference to unveil the complete set of 3 Atlas images, I listened intently. I focused not just on their statements but also on the silences between them. They presented the recent smudges from SOHO, faint traces from Lucy, a halo from Maven, and the same teardrop-like Hubble images we have all examined. However, throughout the 45-minute presentation, a peculiar thing occurred. They completely overlooked the one characteristic of 3 Atlas that should have been the focal point of the discussion. Its size was never mentioned, not once, not even in passing or as a footnote, not even as a brief cautionary note. This omission represents perhaps the most astounding aspect of the entire event. You see, when we study an interstellar object, size is far from a minor detail. It serves as the foundation for every additional calculation. Considerations such as how much material is expelled, the speed of gas flow, the density of the nucleus, its brightness, the impact of sunlight, rotation speed, acceleration patterns, the number of jets it can produce, and its survival duration as it approaches the sun. All these factors hinge critically on the object's size. Yet, NASA completely sidestepped the issue. However, based on the available data, including the Webb infrared limits, Maven's hydrogen, halo, the brightness profile from HiRISE, and scattering efficiency, it appears that the 3 Atlas is huge. A conservative estimation puts its size at 5 kilometers in diameter, possibly even larger. This is not a trivial deviation. It is an extraordinary anomaly. To understand how surprising this is, let's consider the scale. Oumuamua, MUA, the first interstellar object, was approximately 100 meters, while Borisov measured about 1 kilometer. In contrast, Atlas seems to surpass 5 kilometers, making Atlas 1,000 times more massive than Borisov and 1,000,000 times more massive than Oumuamua. Oumuamua, we have only observed 3 interstellar objects, which should reflect a natural distribution, predominantly small objects, some medium-sized and very few large ones. Yet the third object we've identified is the largest by a factor of 1,000,000, raising statistical concerns. It defies the expectation that we would encounter 1,000 smaller objects before finding a giant. Just like if you roll a die, you would expect to land each number many times before rolling a 6 1,000 times consecutively. That's the scenario we face with Atlas. This illustrates why size cannot be dismissed as a mere detail. It is the very puzzle itself. We can analyze this probably. If interstellar space is filled with debris fragments of planets, comets, and asteroids from distant star systems, the most common objects should logically be the smallest. They are easier to eject, move more freely, and exist in far greater numbers. However, Atlas throws this expectation into disarray, and it does so violently. Imagine if the first 2 raindrops on your hand are tiny, gentle droplets, and the third one is a fully formed iceberg. Would you deem that as normal weather? Or would you wonder what kind of sky produced such phenomena? This is the question NASA neglected to ponder. A nucleus of 5 kilometers is not casually ejected from a planetary system. The gravitational energy necessary to propel such a mass into interstellar space is staggering. Planetary scattering can accomplish it, but only under very specific conditions. A binary star system might facilitate it, but only with the correct mass distribution. A planetary collision could expel such a fragment, but the geometry would need to be ideal. In all the scenarios we explore, the probabilities remain remarkably low. This suggests that Atlas originates from either an exceptionally rare environment, stems from an extreme catastrophic event, or was produced by a mechanism we have yet to grasp. Instead of examining these possibilities, NASA opted to entirely ignore the subject. What we received from the NASA event was a series of images. Most were fuzzy, incomplete, and lacking in scientific context. We were shown a blurry frame from SOHO where the comet hardly registered as a pixel. Other observations included a dim glow from Maven's UV camera, a smudged cloud from HiRISE, a sideways tail from Punch, a thermal hotspot from a few dots on a Webb spectrographic plot, and a dusty cocoon from Hubble. While all of these observations are intriguing, none answers the central questions or explains how such a massive object entered our solar system. None addresses its rarity or contextualizes the statistics, nor do they even mention the size. Another peculiar aspect that NASA shied away from is the object's trajectory. The 3 Atlas arrived nearly perfectly aligned with the planetary plane, allowing numerous spacecraft to observe it. Hubble, Webb, SOA, Stereo, Lucy, MRO, Maven, Pump, and even rovers. However, this alignment is improbable. Only 1 in 500 interstellar objects would follow such a convenient path. Rather than presenting this as mere luck, the scientifically appropriate question would be why this occurrence is so rare, and why it happened at this moment. This was never addressed, and once again, ignoring the anomaly does not eliminate its existence. Every significant scientific discovery's foundation lies in something that does not fit the established patterns. Mercury's orbit did not align with Newton's laws until Einstein's theories emerged. The ultraviolet catastrophe did not fit within classical physics until Planck came forth. The photoelectric effect did not adhere to Maxwell's equations until the advent of quantum mechanics. Dark matter did not align with galactic rotations, and we continue the search for answers. When anomalies occur in nature, it is our duty as scientists to investigate them rather than set them aside or treat them as inconveniences. 3 Atlas offers multiple anomalies. Its colossal size nickel-based composition with scant iron, tightly clustered jets despite its rotation, alignment with the planetary plane, unexpected outgassing, far from the sun, inconsistent brightness across different wavelengths, shape, and dust behavior all present challenges to our understanding of interstellar object formation. Together, these anomalies create an increasingly compelling case. Yet, NASA avoided these topics completely. I want to emphasize that I do not believe NASA is purposefully withholding information. Instead, NASA operates as a bureaucracy, not a philosophical institution. Bureaucracies tend to favor safe answers, shunning uncertainty, speculation, or declarations that might incite public confusion or scientific controversy. The size of Atlas leads directly to these outcomes. To acknowledge its size is to accept that our models may be incomplete, and to embrace model incompleteness is to concede that we do not wholly understand the object. This notion is uncomfortable, yet discomfort often drives progress. One of the most unusual aspects of 3 Atlas is its chemical composition. We identified nickel but virtually no iron. This is unprecedented. Nickel and iron typically form together in stars, and in all the comets, asteroids, or meteorites studied to date, iron is more prevalent. The only scenarios where you observe high nickel materials with minimal iron are in aerospace-grade nickel alloys. Now, while I am not asserting that Atlas is artificial, I am indicating that its immense size, peculiar chemistry, rare trajectory, tightly clustered jets, extraordinary mass, and significant water production far from the sun compel us to consider possibilities outside conventional explanations. NASA neglected to mention the nickel anomaly or connect it to the size deficiency. Yet these anomalies do not exist independently. Together, they form a complex picture. Based on observations, Atlas seems to rotate approximately every 16 hours. If this is accurate, the jets should exhibit wobbling or spiral effects due to the rotation. However, they remain straight, stable, and tightly clustered, resembling laser beams of gas. A clear deviation from typical comet behavior. Coupling this with the nucleus's massive size creates a paradox. A large, slowly rotating comet would typically generate broad, curved jets rather than narrow, straight ones. Nonetheless, Atlas does produce narrow jets, leading me to highlight jet clustering as one of the anomalies in my analysis. NASA did not address this point. Let me clarify, I am not suggesting that 3 Atlas is artificial. Rather, I contend it is not yet understood. If it is a natural object, the natural processes that formed it are unlike anything we have observed. It may have originated from a catastrophic planetary collision, a volatile rich moon shattered by a passing star, a Kuiper belt analog vastly larger than ours, a disrupted or a tidal stripping event in a binary system. All of these possibilities are rare, but the mere size compels us to consider them. Moreover, the most insightful observations are still forthcoming. On December 19th, Atlas will reach its closest approach to Earth, which will provide an opportunity for Hubble, James Webb, ground-based arrays, infrared telescopes, radioobservatories, spectrographs, and amateur astronomers worldwide to observe it. We might finally be able to measure the nucleus directly, capture the jets with high resolution, identify volatiles previously undetected, discover signs of an isotropic heating effect, detect a rotational signature, or observe fragmentation events. Regardless of what we observe, the size discrepancy will remain the core mystery. If we overlook the size, we risk ignoring the truth. In science, it is easy to fall into the trap of believing that we understand everything. However, the moment we become overconfident, we halt our learning process. 3 Atlas should not be considered a threat, crisis, or danger. Rather, it is a remarkable gift, a messenger from another star system, offering insights about the formation and evolution of materials in environments that far exceed our understanding. Yet for this object to fulfill its purpose, we must confront the questions NASA chose to avoid. The size is not just a figure, it is a clue that has the potential to reshape our comprehension of interstellar geology, planetary formation, and cosmic evolution.